I'm going to talk a little bit about technology. And more specifically in this device here, graphing calculator. How many people have these? Okay, almost everyone. Okay. So some of what I'm going to say will be things you already know. And maybe some of the little tricks I'm going to tell you about you know, and maybe you don't. These are really useful. These are fantastic little devices. We're not going to use them much in class. Come in much handier in the next class, calculus. But it's good to know your way around one of these. We're doing abstract kind of math, so lots of times the answers these give you are approximations. But if nothing else, when you're doing a problem, you can put it on the calculator, you can at least see that you're in the right ballpark. Right? If you get a totally different answer on the calculator, then you have to think, well, maybe I did my algebra wrong. So they're really fantastically useful for that. They have far more capabilities than even I know about. I mean, you can program them, and you can do matrices and stuff. I'm just going to go over some basic things that I feel are important. Things that will, let me say, I think be important in the calculus class. But first, I also want to say something about obtaining one of these if you don't have one, or maybe something that would be useful if you do. I looked online. You know, there are various models. Even a TI-82 is pretty similar. This is an 83 plus. I don't know. I've seen an 83. I don't know what the difference is. An 83 silver model. I looked online, and it seems like retail you can get something like this between, say, 40 and 100 bucks, brand new. If you go looking on eBay, you can get an even better deal on a used one. I don't know if that's a good or bad idea. If you have an iPhone, right? There's an app that makes your iPhone look just like a TI-83. You'll definitely never get to use that in class on an exam, but that's okay. It's only $7. For Android, it's a bargain. It's $3. And if you're using Windows and you don't really want to buy one of these because you want to play around with it anyway, I have an emulator I can give you for free. It looks just like this. You click on the buttons and it works the same. So if anybody sends me an email, I can give you the emulator. I don't have one for the Mac. I don't even know if there is one. But again, good thing to know about. All right. I guess I have to think about, you know, if I ever do this again, bringing in that emulator and putting it on the PC and actually do something real instead of looking at static pictures. For what we're going to do, which is, you know, looking at graphs of things, the first thing you want to do is you want to hit your mode button and make sure your mode is set the way you want it. I guess there's a bunch of defaults. I'm not going to comment on them because you'll run into them sooner or later. When we get into trig, you'll see there's this radian degree option. If you don't know what radians are yet, that's okay. Alex, would you like a nice shiny bottle with your name on it? Stay here for you. Isn't that nice? Yeah. Okay. Like I say, when we get into trigonometry, the radian degree option, you really want to be careful, because if you find the sign of 0 degrees, that doesn't matter, but if you try and find the sign of 90 and you get a weird number, it's probably because you're in radian mode. But really what I want to talk about here is where the arrow is pointing, which is what mode is the graphic display in. And you see here it's in func mode or function mode. There's some other modes. I don't know if we're going to look at the next one, which is par for parametric, or pole, which is polar. We may. I have no idea what seek is. Who knows what seek is? I think it down the seek is? SEQ. Oh, seek. I have no idea what it does. We could fool around and try. Okay, so first thing you want to do is make sure you're in the right mode. I've had a lot of experience with sitting here and having students come to me and go, my calculator's not working, and then I have to go look at it and figure out what did they mess up. And this is like the first place to start. The next thing you want to do when you're graphing is coordination problem here. Oh, this. How do I get it back? There we go. So you can press the zoom key. You also want to know here that after you press mode, you're in the mode, and you want to get out, and so you hit second mode again, which is quit. That'll get you out. That'll get you out of a lot of things like graphic mode. But you want to hit this zoom key, and that'll give you some starting points for where your display is at. I suggest you start with the zoom box and then work from there. Other things you could try are zoom square, zoom standard, or zoom trig. Zoom in and out are just kind of what they sound like. When you're in some window, zooming out, you're going to go out and you're going to see more. Zoom in, you're going to see less. But this is a good way to start getting the window into where you want it. Oh, I'm sorry. I'm going to suggest 5. Zoom square. I guess I'll change my mind on that. This is something when you're not under the gun or doing an exam, play around with it and learn kind of how it reacts, because it's useful technology. All right, the next thing you might want to look at is the window. You press the window button and you get this little display of values. X min and X max say what the limits on my x-axis are. X scale says what am I going to put a tick mark at? So here we have X scale at 1, meaning 1, 2, 3, 4. That might not come in handy if you zoom out, so you might want to say X scale 5 if you only want a tick every 5. But, that's how you do that. We have the same values you can set for Y. And then also, we're going to have this thing called res. What res is going to do is when you do a graph, if you have res set too small, you have a very small resolution, then it's going to take a long time to display it. But if you have res too big, then your curve is going to look kind of like little straight lines. It's not going to give you good definition of what it is. Again, these are things, you probably just start off taking the defaults, and those will work 90% of the time, but it's helpful to know what these things do. There's a gotcha that I want you to know about. When you're entering these numbers, x min, x max, and so forth, you want to put a negative number. All right. You know, my arrow's in the wrong place. I don't know how I did that. I meant this arrow to point at the minus sign. You'll notice there's two keys that look the same, but they're really different. This is subtract. It's operation. You need two numbers. You don't put in two numbers, it won't work. Here's the negative sign. And what happens is, if you put in a minus in one of those variables, the calculator lets you do it, and then when you try and graph it, just kind of vomits at you. It says, I can't do that, and you don't know why. And if you come ask me, I'll figure it out. But so keep that in mind. There's a minus and a plus, a minus and a subtract on this calculator, which is really, they do different things. All right, finally, we get to the y equals key. Note, when you press this, if you didn't put it in function mode, you won't see this here. You'll see something different. And you'll get confused, and you'll have to go back to mode and fix it. Also, you'll notice on the top of those things that say plot. I have no idea what they do, what they're supposed to do. I know if you put your cursor up there and you hit enter, they'll turn on and off. And then you won't be able to graph anything. I don't know what they do. So if you see any of those turned on, I would turn them off. Then you get to this y equals field. You notice there's a whole bunch. You can actually graph more than one graph at the same time, which is nice. But in general, we're just going to graph maybe one or maybe two functions. And then you use the keys to type in your function. Now, you'll notice, let's see, you can see where I'm pointing, right? So you can't actually see what's here because the cursor is over there. It's an X. But you have to be very careful about what that X actually is. Here I have one of the symbols that means, you know, the exponent, right? In other words, this is going to be x to the fifth. The fancier models go right ahead and they give you a superscript and you just type it in. Of course, on those fancier models, you have to be careful that when you type in the rest, it doesn't all end up in that exponent. So you have to use, you know, the cursor over key. But going back to this x here, so we've got x to the fifth minus 5x to the third plus 4x. The x we're talking about, we have to be very careful about that. It's this key over here, which says xt, theta, and I think n. That's the independent variable key. If you look around on the calculator, you'll see, you know, there's keys that say x to the minus 1 and x squared, 10 to the x, e to the x. Don't use those. You need to put in this independent variable here for it to work right. And when you put in your function, this is one of the great things about the calculator, because it's not doing this algebraically, it's doing it digitally, you can put in any function that we have available. So, I mean, if you just look at the screen, you know, look at the keyboard, you'll see there are a lot of neat functions like log, natural log, sine, cosine, tangent, you can put in there. Inverse sine, you can make something up. You can do a composition of functions, which we'll get to later. We do very complicated things. Also, let me go back a bit, see if I have this. There's a key at the bottom. Well, I guess there are two keys here. I don't have a full picture. Oh, there it is. Okay, so you see over here catalog, that's a shift key. You go to catalog, you'll get a whole list in your display of all the functions the calculator can do, and you can cursor through and pick one you like. In this class, the one you're most likely to want turns out to be conveniently the first one, since they're alphabetical. It's absolute value. So I can plug in absolute value very nicely. There's also another key which will give you a shorter list. Let's see if I can find it. Here, over next to matrix, math. Math will give you a list of some math functions you can use. So. Okay, so finally, after you've typed in your equation here, using the X key, you hit graph, and then hopefully you see a nice little graph here. You can then go back to your window or your zoom screen, adjust the window if you want to zoom in on a spot or zoom out. It goes off the top of the screen. You want to maybe just adjust your X limits and your Y limits. Sometimes you hit the graph key and you see up in the upper right-hand corner a little kind of motion here, and it just sits there and it does that. And that means that the calculator is working real hard, it's thinking, it's trying to show you a graph, but maybe you don't see anything, or you're in an exam, it's taking too long and you want your calculator back. There may be a better way, but the only way I know to get out of this is to use the off key. Turn your calculator off. Let's see, here we go. It's the same as the on button, except you have to hit the shift, the yellow shift key, and you turn it off, and that'll stop it. And then you can go in and try and figure out if you did something wrong. Try again. Sometimes you just set it, you just put in a bunch of values that just take a long time. You could try setting your resolution lower, that might help. All right. A few more comments I want to make about this. Yeah, so once you have your graph up, I'm not going to go into it, but you'll see here, well, I have it blocked out by the arrow, but above where it says trace, you have the calc menu, and below you have the trace menu. And there are really, really kind of fantastic things you can do with these once you have your algebraic function in there. Or things that would be very hard to do algebraically. Like you want to find the intersection of a log function and some polynomial. And algebraically it's very difficult, but the computer's just giving you an approximation, so it can do that. So some of the things it can do is you can use it to calculate the value of a function at a point. So if you enter a really fancy function, now you can use the calculator to give you specific points on it. There's, I guess it's a different menu item. Table. You can use table once you have your function in to give you a list of points on a table. can adjust the increment and where to start. Now, the next things I'm going to tell you about, well, okay, let me say you can find the intersection of two functions. That's one thing you can do. You can put two graphs on and say, I want to find out where they cross. And you give it a little help, a starting point, and it will look for that intersection, approximate intersection. Okay, so now we're going to get, I'm just going to mention some things that when you get into your calculus class it can do. It can find local maximums and minimums very nicely. We may talk about those today even, but not really how to do it. And you can find the derivative at a point, and you can find the integral under a function, things you don't need to know what they are now, but in calculus, they're the main things we do in calculus, so it's really, really great little device here. Okay, that's the TI-83. And just because I told you all these things not to watch out for, and if you ever run into trouble, you're welcome to come and try and figure it out for you too. This is not the only calculator you have available. Let's see if I can, this is a Mac, so there's a program called Grapher, which is, if you happen to have a Mac available, if you own one or you can get a hold of one, it comes with it. Every Mac should have it. This is, again, it's a little different in its capabilities, but you pick a type of graph you want, and then you pick some function you want to graph. Let's just say x cubed. Okay, here you have to watch, right? I'm still up in the exponent, so I have to cursor over, or I'll be surprised at what I get. Minus x squared, minus x, minus 3x squared, you know, whatever you want. And it just pops that graph right up there for you. I imagine there are capabilities that I don't know about here. So again, you know, there's a lot of technology here you can explore. One of the things I really like about this, although I can't defend it, is Grapher, is that it will do 3D graphs, and that are really fun, I think. Show you an example of what I mean. So here I'm in 3D, so I can say x squared minus y cubed. Ooh. Here I have a nice little surface that not only do I get to see it, but I get to move around in it. An oddball thing. If you ever looked at three-dimensional conic sections, this is really a fantastic tool for getting a feel for what's going on. So Grapher is a program you can use with the Mac. Unsave. And then if you have a PC, I just happen to know about this. Someone showed me the other day. There's a website at desmos.com that has a calculator that, as far as I can tell, is a lot like Grapher. It's online. I guess you can get this with a PC or a Mac. Wait a minute. That's not what I want to do. something funny looking, see, experiment around, see what happens. Okay, so it's technology, right? Technology can help us learn math. It will do some math for us. Some things it will just give us an approximation, and sometimes that's all we need. It's also, visualizing math is often a really good way to learn what's going on. All right. I guess I brought up the technology, so I guess I should probably use it a little. So I want to look at a particular family of graphs. Namely, graphs that form y equals x to the n, where n is a natural number and is 1 or greater. So let's try, we'll start with, n even. So here we see a function you're very familiar with, a parabola. And add on here the next even number would be x to the 4th. Looks very similar, right? It's kind of like open upward. You could pour water into it. You can see it goes up faster. That's expected, right? X to the 4th is going to increase or decrease faster than x squared. Let's try one more. Let's try the 6. Okay, same idea. It's just goes up a little faster than x to the 4th, but it's kind of a similar shape. You can kind of see where this is going. As we increase x, as long as it's even, this is going to start moving outward and upward faster. It's going to start looking more and more like a rectangle. Let me just see how good this graphics program is. Let's put in something a little outlandish. Say 80. That ought to do it. Okay. So just as I suggested, it kind of looks like a rectangle. It is actually, it has values all the way out. They're just way off the graph. Okay, so that's, the even ends is kind of a family of functions that you should know what they look like. They could move around, or if you put a negative sign, it could be upside down. Let's look at the odd functions, the odd ends. Well, the first one is kind of dull. Just x to the 1. That's just a straight line. In this case, the intercept is 0. But when I go to the next one, it's 3. In case you're wondering, there's no mouse on this thing. It's just a crappy little touchpad. So that's why I'm struggling here. There we go. All right, so you might be familiar with this also. This is x cubed. The graph is in the first quadrant and the third quadrant, just like the line, except now we've got a curve attached to it. And it increases pretty rapidly as x to the third. And let's just take a look at one more member of this family so we can kind of characterize it here. That's the other thing about technology. You never want to use it when you're like, you know, when your lunar land trying to land. Stops working the way you want, you can be in trouble. Okay, so again, you see the limbs are starting to move outwards towards 1, and I think the pattern is pretty clear. Finally, why don't we just complete our little thing here. 81. And sure enough, that kind of looks like we've almost got straight lines now. It's rising so fast. Okay, so that's just a family of functions. You should be familiar with their graphs. Not much else to say about that. I'm going to put this away, toys away here. Okay, another type of function we talked about Not a black marker there it is. Another type of graph we talked about is a piecewise function. For example, f of x equals, in this case, x squared if x is less than or equal to 1, and 2x plus 1 if x is greater than 1. So there's nothing magic here. In the case of the first part, we know that's a parabola that more or less looks like this, except we're only interested in x less than or equal to 1, so we can eliminate this part. And then this is just again a straight line, right? Its y-intercept is 1 and has a slope of 2. But again, we're only interested in the graph, this part of the graph from greater than 1. So we can kind of erase this. And again, I think everybody knows This is just my way of symbolizing that it's greater than, it doesn't include this point. And that's all there is to graphing a piecewise function. Forget if it was this class that I tried to talk about a greatest integer function, fumbled. We have this symbol which includes double square brackets, and it means the greatest integer less than or equal to x. This is also known more generically as a step function. So just as some examples, well, what's the integer, the greatest integer less than or equal to 1? This is 1. Integer, greatest integer that's less than or equal to 0.5, that's just 0. And there's a negative half. Well, the greatest integer less than that is just -1. Get a feel for what this function does. All right, well, graphing it, I think we'll get a much better idea. So you can see here from just a little larger than 0 up to 1. This is just going to be, the function's going to be 1. But as soon as we get to 1, we're going to jump up here. But again, we're going to continue to be 1 until we get to 2, and so forth. We go negative, and it looks like this. So you can see right away why it looks like a step function. This kind of function will come up in practical applications, such as, well, I guess everybody has free phone calls now, right? But it used to be the phone company would charge you, say, 10 cents a minute. But they would charge you for the minute, whether you used it up or not. So that would kind of look like 0.10 times, I guess it would be minutes, but +1, because the minute you pick up the phone, they start charging. So that would look like this, except if we start here. I'm just going to mention this again because it's in a, yes?
Can you go over that again?
Okay. Greatest, this is just a function we made up that's useful for some, it comes up in mathematics too, but it, you know, like I say, it comes up a lot when you're dealing, like, say, with a phone company, and they say, we're going to charge you X amount until such and such happens, and then we'll charge you more. The symbol is just double square brackets, and you plug a value in here, and you look at it, and you say, is it an integer? If it is, that's the value. It's 1, it's 1. If it's a fractional value, you say, well, what's the next integer less than that? Right? It's the greatest integer, which is less than or equal to this. So less than or equal to 0.5 would be 0. I said 14.6. What would the value of this be?
15. 15?
Well, that would be a different function. That would be the function that the greatest, the least integer greater than this. No, the greatest integer less than or equal to 14.6 would be 14. Does that make sense?
So it can't be a decimal, it's zero.
Yeah. I mean, the output of this is going to be an integer. Question is which integer? Well, if you plug in an integer, it's that integer. Otherwise, it's the integer. It's like you truncate it, right? The only thing you have to watch out for is, say the greatest integer of 23 is not 22, it's 23. Is that okay? And it is kind of a confusing function. I don't know what the symbol would be, but there is an equivalent function, the least integer greater than or equal to x, and that would, for this it would be 15, this it would be 23, this it would be 0, this would be 1, for this it would be 1. It's another step function. Okay, I just want to remind everyone of something we talked about on Wednesday, which is the vertical line test. And I want you to convince yourself that this step function, no matter where you draw a vertical line, you just hit one point. So it is a function, right? It does pass that test. All right. Any questions on any of this? All right. So I want to look at. I think I talked about this graph before. X squared plus y squared equals 1, which is just a circle, radius 1, and I think we mentioned this is clearly not a function. Right? Because, among other things, it wouldn't pass the vertical line test. For each x, at least between 1 and -1, there are 2 values. But we can make it a function. We can say y equals square root of 1 minus x squared. And that would be just the upper part of this graph. There's another function, y equals minus the square root of 1 minus x squared, which of course would be a different function, and it would be underneath. We don't care so much about that right now. So one thing I want you to look at in this graph is some information about its domain and range. Sometimes a graph will give you information that's just by looking at it. So since the range is since the domain is the values that you can plug into this function here, if you look at this graph and we just look along the x-axis for places where the graph exists, you can see that right away that the domain has to be this interval -1 to 1. You get excessively fancy for me here, so you can see the graph here. Likewise, I can look at this graph and say, well, what's the range? Well, the range is the y values. So merely by looking at the graph, I can see that the range goes between 0 and 1. So that's an example of something where you can determine domain and range by looking at the graph. Let's look at another example. These are pretty simple examples, but so let's say I were to graph y equals x squared. Well, here you can kind of see, I mean, that this graph is going off in both directions. So its domain is, all the reals, or if you like, from negative infinity to positive infinity. But similarly, you can see that the range is only things above the x-axis. So the range is just going to be from 0 to infinity. Note this is a feature of that entire family we talked about, where the exponent is even. In contrast, you can see for the function y equals x cubed, the domain will be the same, but the range, of course, is not limited the way the parabola is. It's all real numbers. So this is just something, looking at a graph, you might, you can extract from. Right. I want to say something about the subject the book talks about, which is solving equations graphically. So the example the book gives is you have something like this: 2x squared plus 3 equals 5x plus 6. Well, we could do a couple things with this. We could bring everything over to one side and then treat this, one side of the equation as y, and then we can find the parabola, and we can see where the parabola, find out where the parabola crosses the y-axis. But the book wants us to go about it a little differently. They want us to break it up into these functions: 2x squared plus 3, and say g of x is 5x plus 6. The idea is you would draw a graph, and you would find that this parabola is going to go through the axis of 3, right, 0, and like this. So we have some kind of tight graph paper here, so we'll plot some points and get this right. And then 5x plus 6, well, that's just a line it goes through the y-intercept here at 6, and it's got a slope of 5. And we could then look at this graph and see where it happens to intersect. Now, unless you're on a desert island with a nice sandy beach that you can draw graphs on, no calculator, and no idea what you're doing otherwise, I don't think this is a very good idea. In some circumstances, you know, these won't be nice functions that we can do things algebraically, right? In which case, use your calculator. Have your calculator do this for you. I like the idea of visualizing this, but actually using this as a method to solve a math problem, that would be, you know, kind of Neanderthal. I mean, we know how to manipulate this thing algebraically. It may not be as transparent as happening, but that's what we should do. So again, you know, the book emphasizes this for reasons I don't quite understand. You should know about it, but again, I'm trying to dissuade you from using this as a method. Right. Okay. We're going to switch gears now. We're we keep looking at some graphs, but we're going to talk about a few new concepts that are going to be very important in this class, and even more so if you go on. So I might have some graph I'm looking at, of some function, and it might do all sorts of things. And I might want to look at a particular part of the graph here, from here to here. Just on this interval here. And I want to make an observation about it, which is it's going up. Okay? On this entire interval, it's going up. Well, we have a name for that. This is a function, or interval on a function. Function where the function is increasing. Or we can call it an increasing interval of the function. In particular, we would say x is a member of some interval AB, and A less than B implies that f of A is less than f of B. Then we have an increasing function on that interval. This is the definition. If somehow we were, say, blessed with a function like y equals x cubed, where the interval that it's increasing is the domain, right? Domain, in this case, minus infinity to infinity. If this is true on the entire domain, then we would just say this is an increasing function. I've been doing this too long, so to me I look at this and it's really obvious, but if it isn't, you should let it sink in. What does this mean? We have 2 points, A and B. And A is over here and B is over here. And f of A is down here and f of B is up here. And that's true for any 2 points. It's a very precise definition. It might seem a little awkward, but we might use this later when we're not looking at graphs, when we're looking at something algebraically to show that that's the case. You have an increasing function. Now, of course, as soon as you have an increasing function, you know, all the same thing, all the same definitions, slightly modified. They're on a function where it's decreasing. Okay, well, what would that look like? That would look like A less than B implies what? F of A is greater than F of B. Okay, so that's, now we have a definition for increasing on an interval or an increasing function. If you have a function which is either increasing or decreasing, we have a fancy mathematical term for that. This is called a monotonic function. So if the function goes up and down, it's not monotonic. It just goes up, it just goes down. Okay. I think I'm going to stop here.